Hello everyone. Today I'm going to be teaching you about Unit 1 of Chemistry. So a brief summary on what we will be covering in this video. So Unit 1 of Chemistry covers a multitude of different things, but it is mainly categorized under the term matter. In this video we will cover the scientific method, elements and compounds, physical and chemical changes and properties, pure substances and mixtures, SI units, scientific notation, and significant figures, states of matter, and phase changes. The scientific method is a step-by-step process that scientists use to test a hypothesis and experiment. Elements and compounds together work from atoms, either singular or plural. Physical properties are things that we can see on the outside that do not change what something is made of, while a chemical property changes the inside of what something is composed of and turns it into something new. Matter is composed into two categories, pure substances and mixtures, which then break down into elements and compounds. SI units are the standard form of the metric system used to convert different units of measurement. Scientific notation expresses large and small numbers into a neat decimal form. Significant figures allow us to find the numbers that have significance to a measurement. States of matter are the different ways matter can exist. Lastly, phase changes shows how the different states of matter phase into one another. So that is the basic summary of what we will be covering. Some additional vocab that is good to know. I will be reading every single definition, so skip if you would like to. Observation, any information that is gathered with the senses. Prediction, a guess on what might happen based on an observation. Independent variable usually changes and has a direct effect on the dependent variable. Dependent variable, the variable that is being tested and measured in an experiment and is dependent on the independent variable. Control group, the standard to which comparisons are made in an experiment. Graph, a diagram showing the relationship between variable quantities, typically of two variables, each measured along one of a pair of axes. Theory, a well-established explanation for scientific data. A theory can typically change as new information is processed, but usually is never proven. Law/principle, it refers to the rules for how nature will behave under certain conditions. It will always be proven, and you can always find an explanation for it. Matter is any substance that has mass and takes up space by having volume. Solution, a special type of homogeneous mixture composed of two or more substances. Usually a solute and solvent are within a solution. Colloid. A colloid is a phase-separated mixture in which one substance is suspended throughout another substance. Suspension is a heterogeneous mixture that contains solid particles. A solute is a substance dissolved in another substance, and a solvent is a substance that dissolves a solute. Alloy is a metallic substance composed of two or more elements as either a compound or a solution. Emulsion, mixture of two or more liquids in which one is present as droplets distributed throughout the other. Chromatography is a separation of a mixture by passing it in a solution through a medium in which the components move at different rates. Evaporation involves heating the solution until the solvent evaporates, turns into a gas, leaving behind the solid residue. Centrifuge uses a centrifugal force to move dense components to the outside of the container. It causes the solid to settle more rapidly and completely. Distillation, the action of purifying a liquid by a process of heating and cooling. Freezing, in ways of separation. Freezing is used to separate components that have different melting points. Filtration, used to separate pure substances in mixtures composed of particles, some of which are large enough to be captured with a porous material. Law of conservation of mass. The law states that matter cannot be created nor destroyed, it can only be transferred. Intensive, does not intensive properties mean they do not depend on the amount of matter in a sample, and then extensive properties mean it depends on how much matter a sample contains. Metric system, a system of measurement that uses the meter, liter, and gram as base units of length, distance, capacity, volume, and weight, mass. Prefix, a unit prefix that precedes a basic unit of measurement to indicate a multiple or submultiple of the unit. Conversion factor, a number used to change one set of units to another by multiplying or dividing. Equality, an expression of quantity into different units. Exact number can only be expressed in one way and cannot be simplified any further. And measured number, numbers with a value that is not exactly known due to the measuring process. Now that vocab's out of the way, we can start. So the scientific method. So starting with question. Question uses your 5 senses to observe and form a question that is measurable and repeatable. An example is, does water freeze faster on its own or with sugar added? So research. Find out what's already been written about your question. Can help you specify what you want to test and already have some background info. Example, researching and finding out about previous tests on water freezing. Hypothesis. A possible explanation for a set of observations or an answer to a scientific question. It must be testable and measurable. Example, if sugar is added to water, then the water will freeze faster. Usually we are taught as it is an if-then statement, but usually in chemistry it is an if-then-because statement. Experiment. A scientific procedure undertaken to make a discovery, test a hypothesis, or demonstrate a known fact. Example, putting sugar in 1 cup of water and leaving another cup with just water and cooling the temperature to see which freezes faster. Data. Gather your results from the experiment, then interpret the data, put into charts or tables to look for patterns and other relationships. Example, out of 5 trials, the water froze quicker 4 out of 5 times when sugar was added. Conclusion. A summary of what you have learned from the experiment. Does your data support your hypothesis, and why or why not? Example, seeing that the water will freeze quicker when sugar was added based on the data supports our hypothesis that if sugar is added to water, then it will freeze quicker. So now elements versus compounds. Element. Any substance found directly on the periodic table and cannot be broken down into smaller atoms. Example, helium, carbon, oxygen, and gold. Compounds. 2 or more chemically combined elements that can be broken down into the respective elements. H2O, carbon dioxide, and as you can see on the screen, ammonia, hydrogen peroxide. Physical and chemical properties and changes. Physical properties. Properties that can be observed without altering the identity of the substance. Examples, color, length, state. Physical changes. Physical changes that happen without altering the identity of the substance. Example, painting a piece of paper, candle melting, water changing into ice, or vaporizing. Chemical properties. Properties that are only observed when the identity of the substance is changed. Chemical properties include combustibility, flammability, toxicity, reactivity. Chemical changes. Changes that are only observed when the identity of the substance is changed. Forming rust, burning wood. Example. In this picture, it's kind of blocked by my face, but it's wood before it burns and then it turns into ash, which is a new substance. Next is pure substances and mixtures. Pure substance, either an element or a compound. Example, hydrogen, water. Mixture. A physical mixture consists of 2 or more pure substances that are not chemically bonded. Example, air. Air is a mixture of gases that all just coexist unbonded. Examples of mixtures, or mixtures can be broken down into homogeneous and heterogeneous mixtures. Homogeneous mixtures are uniform in composition. You cannot see the different parts of the mixture. That includes steel, air, rain, Kool-Aid, salt water. Heterogeneous mixtures, or heterogeneous mixtures, are mixtures that are not uniform in composition. You can see the different parts of the mixture. Example, oil and vinegar, cereal and milk, mint chocolate chip ice cream, ice and soda. So next is SI units. SI units, they are the modern form of the metric system, a set of prefixes used to indicate multiplication or division by a power of 10. Example, meter, kilogram, second, ampere, Kelvin, candela, and mole. So an example problem would be how many centimeters are in 1 meter. So usually your base unit will not have a prefix to it. Base unit includes the meter. So the meter is 1, if you can see that, is 1. On our picture, you can see that moving to the right, you will move your decimal to the left. But as you go to the left, you move your decimal to the right, getting bigger. Because as you go to the left, it gets bigger. As you go to the right, it gets smaller. So your decimal is put here, obviously. And we are making it smaller, so it goes to the left. 1, 2. Because you can see centimeter is 2 away from our base units. So add the 0, and your answer is 0.01. As you can also see, it is on the image on the screen. So next, you have scientific notation and sig figs, which stand for significant figures. So scientific notation is when a number between 1 and 10 is multiplied by a power of 10. Those are some examples. 45,000 can be written into 4.5 times 10 to the 4th. Or it can be into smaller. 7.6 times 10 to the negative 4th is that number. Next is significant figures, which is digits of a number that are meaningful in terms of accuracy or precision. So there are many rules. The rules include any whole number, zeros between two significant figures, and zeros at the end if there is a decimal point. Zeros at the beginning and zeros at the end with no decimal point are not significant. Example, so out of 250, the only numbers that count is the 2 and the 5. Because there is no decimal, the 0 does not count. Now, if it was 2.05, all the numbers count, because the 0 is in between two numbers that are significant. States of matter. So we have 5 states of matter. Bose-Einstein is the first one. So it is when gas of bosons with low densities are cooled very close or at absolute 0. An example is superfluids. Next is solids. Solids are lower temperature, slowly moving particles that are compact together, placed in regular repeating patterns. Example, wood, ice. Liquids, medium temperature and somewhat freely floating particles. Water, milk, any other liquids you can think of. Gases, higher temperature, freely and fast-moving particles, high energy and usually far apart from one another. Example, steam, helium, bubbles, fumes. And plasma, ionized gas whose atoms have lost all or some of their electrons. Does not have a definite shape or volume. Example, the sun, and plasma can be found within your blood. Phase changes. Ionization and recombination. Turning gas into a plasma or vice versa. Example, sodium and chlorine mix to make salt. Vaporization. Liquid phases to vapor. Boiling, evaporation. And you could see, like, from the steam of a cup. Condensation. Gas phase to liquid. Example, fog on glasses, morning dew. Deposition. Gas phases to solid. Frost forms on a leaf is our example. Sublimation. Solid phase to gas. Example, dry ice. Freezing. Liquid phase turns to solid in cold temperatures. Example, water to ice. Melting is solid phase to a liquid. Example, ice to water. And that is Unit 1 of Chemistry. I hope you guys enjoyed this video and learned a lot. Anyways, that's it. Goodbye.